Hey everyone, and welcome to Mastering Distributed Caching for Scalable Systems. In today's lesson, we're diving deep into a topic crucial for any high-performance application. By the end of our time together, you'll be able to truly understand why distributed caching isn't just a good idea, but a necessity for scaling. We'll explore practical strategies like cache sharding, which is how you spread your data across many servers, and smart warming, where you predict what users need before they even ask. You'll also grasp the complexities of maintaining geographic cache coherence, ensuring your data is consistent worldwide. Ultimately, my goal is for you to walk away with the knowledge to apply these concepts and build truly robust, high-performance systems that can handle millions of requests per second. Let's get started. Imagine a major social network like Instagram when it first hit 100 million users. Every single timeline, profile, or trending topic request was hitting one central cache server. This quickly became the system's Achilles heel, creating a massive bottleneck. The solution, as they discovered, was to move beyond a single cache and embrace cache sharding. Think of it like a grocery store, moving from one overwhelmed cashier to a dozen specialized checkout counters, each handling a specific line. Cache sharding splits your data across multiple Redis instances based on keys, turning one overworked server into a fleet of specialized ones. The benefits are clear. You get horizontal scalability, meaning you can just add more cache instances as traffic grows, and crucially, fault isolation. If one cache fails, it doesn't bring down your entire system. This parallelizes the load, dramatically improving overall performance. But how do we make sure these shards are always ready with the right data? That brings us to cache warming. It's like a restaurant preparing all its ingredients before the dinner rush. When instead of waiting for users to request data, leading to a cold cache miss, we proactively preload popular content. This isn't just guessing, it's based on intelligent strategies. We can use time-based warming, like loading morning trending topics before users even wake up. Or pattern-based warming, where we might cache content from a celebrity just before it's expected to go viral. And for global systems, geographic warming preloads regional content based on local events. In a system like our Twitter example, this distributed caching layer sits directly between your application servers and your databases. It's designed to slash database load by up to 90% and boost response times from hundreds of milliseconds down to tens. This proactive approach ensures our system remains responsive and efficient, even under immense pressure. So how does this all come together architecturally? Our distributed caching system relies on four key components: the cache router, which uses consistent hashing to direct requests, the shard manager, overseeing Redis instances and failover, the warming engine, proactively loading content, and the coherence manager, keeping data consistent across regions. When a user requests their timeline, an application server generates a unique cache key. The cache router then uses consistent hashing to direct that request to the correct Redis shard. If the data's there, a cache hit, it's returned instantly. If not, a cache miss, the system fetches it from the database and then populates the cache for future requests. Simultaneously, our warming engine continuously analyzes patterns and predicts what to preload, ensuring those regional caches are always ready. This intricate dance of components ensures both speed and reliability. How do you think consistent hashing helps distribute load evenly across these shards? Now, with data spread across multiple regions, one of the biggest challenges is cache coherence, ensuring consistency. We manage this through various data states: fresh, meaning data is current everywhere, stale, where some regions might have outdated information, invalidating, the process of removing old data, and warming, as we just discussed, loading fresh data into regional caches. Mastering these transitions is key to preventing users from seeing outdated content. So, to recap our journey, we started by understanding the critical bottleneck a single cache creates and how cache sharding provides horizontal scalability and fault isolation. We then explored cache warming, a proactive strategy to predict user needs and preload data, drastically improving performance. Finally, we looked at the architectural components and the vital role of cache coherence in maintaining data consistency in a distributed environment. By applying these principles, you're well equipped to build systems that can truly scale. As a self-assessment, how would you design a warming strategy for a brand new product with no existing user patterns?